All right, the next thing I want us to talk about is correlation. So correlation exists between two variables when higher values of one variable consistently go with higher values of another. So let's take a look at this. I've got my x right here, I've got my y. So if I'm constantly getting higher values of one variable with another variable, this is going to have positive slope, right? So they have positive correlation. Or when higher values of one variable consistently go with lower values of another variable. So for instance, as x increases, y decreases. We'd see something with a negative slope. Okay, so those are the two types of correlation we're going to be looking for. Negative correlation and positive correlation. So, here's some examples of correlation. So, there is a correlation between the variables height and weight for people, right? Taller people tend to weigh more than shorter people. There's also a correlation between the variables demand for computers and price of computers, right? So, as demand increases, price increases. That tends to be true for anything, right? As the demand for a product increases, the price goes up. There's also correlation between practice time and skill among piano players. That is, those who practice more tend to be more skilled, and this makes sense, right? Those who study more tends to do better on exams. So those are examples of correlation. It's important to note that correlation does not imply causality, okay? One doesn't always cause the other. My favorite example is the number of ice cream sales increase, the number of children who go to the ER with broken arms increases, okay? Now, ice cream does not cause broken arms, but what is our underlying variable? Summer, right? So this correlation could be a coincidence. So if I have a correlation, it could be a coincidence. There might be an underlying cause. For example, with my ice cream broken arm scenario, it would be summer. Or one of the correlated variables may actually cause the other, okay? But note that even if that is the case, it could just be one of several causes. And this takes lots of studying to prove. So let's take a look at some examples of are most likely for the following. So for part A, the correlation between infant mortality rates and life expectancy. So as infant mortality rates decrease, life expectancy increases. Okay? Is this a coincidence? Maybe there could be some underlying cause, for example, access to health care. I don't think that one effect actually causes the other in this case, okay? So, next, the correlation between the increased number of geese and the decrease in ice cream sales. So all the geese come in the fall, and it gets cold, and nobody wants to buy ice cream, right? So the underlying cause of this correlation would be it's getting colder. So they have a common underlying cause. Last but certainly not least, number C, the correlation between, part C, the correlation between time students spend studying and their grades, okay? Is this a coincidence? That students who study more get better grades? I don't think so. Is there some common underlying cause? Not quite. One of these variables, so time spent studying, actually affects your grades, okay? So one causes the other. Here we have a true cause.